Right now, the world is in the middle of a massive AI gold rush. Tech giants are locked in this crazy arms race, all trying to build the biggest, baddest AI model you can imagine. But what if that entire approach is about to run smack into a dead end? Let's get into it. The philosophy driving the whole industry today is pretty simple. Bigger is always better. More data, more parameters, more computing power. But this constant push to scale up is creating an arms race that might not just be unwinnable, it might not even be worth winning in the first place. And that really brings us to the biggest question of all. Is this whole revolution about to hit a massive immovable wall? We're going to dig into a paper that argues, yep, it is, and it offers a pretty radical way out. For years, the holy grail has been artificial general intelligence, or AGI, a single AI that can think and reason just like a human, but across any topic imaginable. And the assumption has always been, hey, if we just keep making these models bigger and bigger, AGI will just sort of emerge from the complexity. But that big assumption, well, it's starting to crash into some very hard, very real limits, both physical and logical. That bigger is better road we've been on is starting to look less like a path to AGI and a lot more like a path to a complete breakdown. So what we're seeing is a perfect storm of three huge problems. First, the costs, energy, water, you name it, are becoming absolutely astronomical. Second, for all that power, the models are surprisingly bad at deep critical thinking. And third, the internet data they're all trained on is, let's be honest, a complete mess. Let's just talk raw numbers for a second. An analysis estimated that a single training run for one of these next-gen AI models could use up to 11 billion kilowatt hours of electricity. To put that into perspective for you, that is enough energy to power 1 million US homes for an entire year, for one training run. It's insane. And the really wild part is something called inference inflation. See, the big cost isn't just training the AI, it's actually using it. These so-called reasoning models, the ones that are supposed to think before they give you an answer, they can use up to 79 times more energy and almost 100 times more water for every single question you ask them. That's the staggering hidden cost of just making them seem a little bit smarter. So for all that cost, are they even really reasoning? This quote just hits the nail on the head. These models are incredible pattern matchers, but unless they're working with something that's already super structured, like math or computer code, their so-called reasoning is often just a very shallow imitation. They don't really get it. Okay, so if going bigger and bigger isn't the answer, then what is? Well, this paper suggests a fascinating, totally counterintuitive solution. Instead of building one giant, all-knowing brain, we should be building a whole society of small, specialized experts. It's time to go small. And this is the core idea right here. Domain-specific superintelligence, or DSS. The thinking is, forget the jack-of-all-trades AGI. The real goal should be to create an army of masters, each one a superhuman expert in its own narrow field, trained only on the best, most pristine, reliable data we have. Let's just break down the difference here, because the contrast is pretty stark. The old path is all about one huge model, fed messy data, trying to achieve breadth. The new DSS path is about using many small models, fed clean, expert data, to achieve verifiable depth. It's a complete shift from a game of quantity to a game of quality. So, how in the world do you get a small model to reason so deeply? Well, the secret isn't just about using better data, it's about teaching the model the underlying rules of a domain. It's about teaching abstractions. What even is an abstraction? Just think of it like the core logic or the fundamental structure of a topic. It's the ability to see the forest for the trees, to understand the rules and the relationships, not just memorize a million different examples. This, right here, is the bedrock of real thinking. And this analogy just illustrates it perfectly. A giant, monolithic AI learns by looking at millions of pictures of buildings. And yeah, it gets really good at recognizing what buildings look like. But a DSS model, it learns from the actual blueprints. It understands the structure, the physics, the function. It knows why the building is standing in the first place. The process to do this is actually pretty elegant. First, you build that blueprint, a structured map of expert knowledge, kind of like a knowledge graph. Then, you use that map to generate a perfect synthetic training curriculum. And finally, you train a small, efficient model on that curriculum until it completely masters the logic of that domain. Okay, so you've built these little genius models. Now what? How do they solve really complex problems that cut across different fields? Well, they don't work alone. They work together as a society. This idea actually goes way back, inspired by the AI pioneer Marvin Minsky and his Society of Mind theory. You have a lightweight little AI that acts like a project manager. It takes a complex problem, breaks it into smaller pieces, and then sends each piece to the right expert AI for the job. And what's amazing is that this process works incredibly well. What you're seeing here is how a model gets trained on simple 1 to 3 step reasoning problems. But the key part, the absolute magic, is that because it learned the abstract rules and not just the examples, it can then generalize to solve much, much harder 4 or 5 step problems that it has never even seen before. This whole approach creates something you can think of as Lego-like composability. It's awesome! Need an AI to help with biotech research? Okay. You just snap together a biochemistry expert block, a legal expert block, and a data analysis block. It's modular, it's flexible, and it's ridiculously powerful. So, what's the ultimate payoff of this whole go small philosophy? Well, it's not just about building better AI. It's about creating a future for artificial intelligence that is way smarter, far more sustainable, and actually accessible to everybody. The benefits here are just enormous. It's sustainable, using a tiny fraction of the energy. It's democratic because these small, powerful models can run on your phone, not just in some billion-dollar server farm in the desert. And maybe most important of all, it's reliable. Because it's grounded in facts and logic, it doesn't just make stuff up. When you actually put these two paths side by side, the choice becomes crystal clear. One path leads to centralized, prohibitively expensive, and pretty unreliable systems. The other path leads to distributed, accessible, and highly reliable intelligence for everyone. Which really brings us to our final big question. Does the world truly need one single, all-knowing artificial general intelligence? Or would we be far better off with a whole world of collaborating superhuman experts? The answer to that could very well define the entire future